Now we're moving from the satellites themselves to their use and processing of the data acquired by them. And the satellite data processing starts from the receiving station. And now we have the pleasure to give the floor to a representative of company SCANEX, Ilia Farutin, who will tell us about this. Hello, dear colleagues. First of all, I'd like to thank organizers for this opportunity to make a presentation. In the beginning of my presentation, I'd like to say a few words about what we do. For those people who were not in touch with us, our main idea was to combine the full cycle of technologies related to one way or another to the technologies of space imagery. First of all, as it was just mentioned, we do manufacture universal receiving station. Also, we develop software for primary and additional processing of this data in our GIS technologies, and also we do all sorts of monitoring and thematic projects in various fields. The theme of my presentation is identified as a direct reception and dissemination of remote sensing data at the national scale, and I will explain why. And I will tell you about our vision of this problem. In the beginning of my presentation, I borrowed some of the slides from the European Space Agency, and now almost 4,000 objects, either operational or non-operational, are on the orbit. Out of them, 1,255 are working satellites. Out of them, 310 would be remote sensing satellites. Besides, according to the most recent Euroconsult report, in the next 7, 8 years, 400 to 800 remote sensing satellites are going to be launched. In the next 10 years, Euroconsult forecasts launch of another 12 to 1,400 remote sensing or satellites. And the more satellites we have, they have different specs and characteristics, different swaths, different geometry. The more characteristics they have, the better we can combine them and apply them in different areas of economy. Now, we use them very often in agriculture, in forecasting the yields of our winter crops. In forestry, they're used to follow the boundaries of the identified or allocated plots for clear cutting and also for the forest cadastre. In all sorts of operational services and monitoring services, like, for instance, oil spill detection. This is closer to environmental impact assessment, detection of vessels, emergency management. It could include operational monitoring of forest fires based on initially on low resolution data. Then we can, upon request, provide mid and high resolution data. Could also be spring floods, regular floods, and so on and so forth. Also, with the advent of the super high resolution materials, now we can have a detailed monitoring of construction sites. Like here, for instance, you can see how one of the Moscow boroughs are developing. And we had another interesting project. It is a monitoring of illegal activities of companies. Here you can see, for instance, a factory producing alcohol, whose license was revoked. Originally, they had to suspend their activity, but we see that trucks keep coming, they get loaded and take it away. And in the first year of this project, I think we have identified about 300 factories who continued their illegal activities, and relevant sanctions were applied to them. Also broadly used, this technology is broadly used in meteorology, like the Hurricane Patricia, which created some problems for our rivals, but fortunately it didn't boil down to anything serious. There are different methods of acquiring remote sensing data. Of course, it could be you could simply buy these data from a distributor or satellite operator, or you can get this data as a service, which is actively developed by many companies now. If we're talking about at a national scale, it could be development of own satellite to be totally independent. Our approach here is a bit different, and we've been promoting it for more than 25 years throughout the existence of our company. For many countries, perhaps it is more relevant instead of developing their own satellite, for which you need a lot of investment, both in terms of time and funds. Initially, you can simply install a ground receiving station, which will allow you to get data directly from different satellites, and these data will be accessible for processing and analysis within minutes or dozens of minutes after acquisition. What are the main advantages of such an approach? First of all, you'll get the data in real time when you really need it now, and you don't need to wait for a month, because if you have your own ground receiving station, you can do your own planning, and all of it has to be agreed based on a certain protocol and procedures with the operator of this acquisition system. So if we're talking about other companies' satellites, of course. Also, it is a higher flexibility products, because when you receive this product, you have it in raw form. You can do whatever you want with that. Also, with time, when working with a receiving station, you start accumulating your own archive that you can use also for your internal projects, for analysis of change detection. You don't need to go back to somebody and wait for the retrieval of this data from archive. For instance, if we're talking about national scale, compared to the launch of a new satellite, the price of a parabolic dish and rent of resources of other companies' resources will be much lower, of course. And additionally, you have a reduction of price of a single scene if you buy it from a distributor instead. Of course, it means that you'll have to do certain volume within the resource that you are renting. And the universal approach or versatility for each ground receiving station can be customized for any type of satellite very easily, sometimes by just reconfiguring the software. Sometimes we need to send our specialists to do that. Speaking about our background in working with these systems, now we have supplied more than 250 stations in the world. We started from Ilia stations. They were analog stations that could receive only meteorological data. After that, and there were a number of iterations, and now the main technology that we have is UNISCA station. Here you can see the geography or supplies only for UNISCAN stations. We have more than 80 of them supplied to other countries. About 25 of them are working beyond the borders of Russia to the national remote sensing centers of Iran, Vietnam, and many other countries. What is the remote sensing center made up of? It's not only hardware, it's also a data processing system, and what is important for the delivery of the data, it is the dissemination system, which is important. As previous programs mentioned, or rather previous presentations mentioned, we're talking not about provision of acquisition, but provision of information, and we provide same information using online channels. What is UNISCAN? UNISCAN is a hardware and software complex made up of the antenna and the system, with its own dedicated software, flight plan, and the recording of the data themselves. Each station covers an area, or rather coverage area is about 12 million square kilometers. The reception at the moment is possible from different satellites, both Russian and foreign ones. And the second component of the station would be demodulators that are receiving channels. The satellite could either upload it to 1 or 4 different channels, like the Israeli satellites can do it simultaneously in 2 bands or in 4 bands or channels. Now our stations are supplied with terminals with up to 750 megabit per second per one channel, and you can have up to 4 channels like that. A second component would be the processing system. First of all, they include the pre-processing system. When the station is recording data, this data is recorded in a certain raw format, like a set of zeros and ones that you have to take a picture from, or metadata. And for that, naturally, we cooperate with all leading satellite operators, and jointly with them, we can supply such a terminal for pre-processing. All the standard products will be generated in automatic or manual mode, depending on what you would wish it to be. And a system of additional processing. Of course, here we supply mostly our own in-house processing software, which is used for photogrammetry, for satellite images. We are not working with UAVs or flyers. We stick to our niche of space imagery. Also, additional methods of classification, like change detection, specialized algorithms for SAR, data processing, 3D modeling, and so on and so forth. Here you can see a brief depiction of some of the main functions of our software, which is supplied in the package of the with the station. And many procedures, when we speak about quick delivery of information, many procedures can be automated. After pre-processing, some standard additional processing is done, and then these data are automatically submitted to the customer. And the concluding part of the systems would be a system of providing access to this information. Here we developed our own web GIS system, which is called Geomix. In fact, this is a platform for the development of geoportal solutions or geoservices. Now, perhaps it is possible to do in 2 ways: in local mode, when the program can be fully deployed at a server along with the station, what most often happens with the remote sensing center. And second mode of working with the system would be a cloud solution. You get, in fact, a login password with access to the system, and using simple web browser, you can just combine all sorts of spatial information, images, maps, tables, pictures, and overlay video, and analyze it in such form. What does it look like? Here you can see a simple description speaking about a cloud system. This cloud, with all this information that you uploaded there, can serve as a server to then share it with other systems. You can keep uploading it to your own GIS, geoportals, and so on. And here, as an example, like it works in Russia, like our service of agricultural monitoring called Cosmos Agro is working. So insurance companies and food producers are provided access. They don't need images, they need information. Recently, at an exhibition or conference called Golden Autumn, we had a joint workshop with Airbus company. It was quite a success, and they are using this product now. And everything is done in online mode. These data are automatically received by our stations, processed, uploaded to the project, and the user can see the map that they want. For agricultural producer, doesn't need to know about the satellite specs. They need to know that green is good, red is bad. So we can easily implement it in this way. And this is a final chain in our link in our chain, and this is a simple delivery method which doesn't require any additional skills from the user. All you need to do is know how to use internet, and the rest is just instructions what buttons to press. Actually, that's all I wanted to tell you today. If you have any questions, I'm ready to answer them. Thank you very much. Will there be questions for Ilia? Then I have a question. Perhaps some satellite data can be acquired totally for free. Yes, mostly it's the free data are meteorological data. They're low-resolution data. In all other cases, you work as intermediary to make sure that your buyer signs a contract with the satellite operator. Not in all cases. If we speak about the area where our contracts with operators are in effect, like Russia and some CIS countries, you don't need to sign anything. We have exclusive rights there, like Spot 67 in Belarus, and we license companies for the reception of data. We supply to them the SCANEX developed terminal that we developed jointly with Airbus. If we're talking about RSB, then the situation is the same, and RadarSat is the same. If we speak about foreign supplies, yes, then we jointly with the operator supply this terminal and integrate them into the overall structure. More questions? What is the size of an antenna? Now, in standard packages, we supply antenna of 2.4, 3, and 3.7 meters, and technically, within 6 months, we can supply an antenna with up to 5-meter diameter. No more questions. Thank you very much, Ilia, for your presentation.